just when scientists thought the James Webb Space Telescope couldn't surprise them anymore. It did it again. Every few months, a new discovery emerges from the data collected by the most powerful space telescope ever built. And almost every time, astronomers are forced to ask the same question. How is this possible? The James Webb Space Telescope wasn't designed to search for aliens. It wasn't built to find mysterious objects that break the laws of physics. Its mission was something even more ambitious: to look farther back in time than any telescope before it, to study the first galaxies, to analyze the atmospheres of distant planets, and to help answer some of the biggest questions in modern astronomy. But almost from the moment it became operational, Webb began finding things that no one expected. Galaxies that appeared too large, too bright, too mature. According to our current understanding of the universe, galaxies formed slowly over billions of years. The earliest galaxies should have been small, chaotic collections of young stars. Instead, James Webb found massive galaxies that already seemed remarkably well-developed when the universe was only a few 100 million years old. That may not sound dramatic at first, but think about what it means. It's like opening a history book, turning to the first chapter, and discovering a modern city where there should only be small villages. Something doesn't seem to fit. Astronomers immediately began checking the data. Had there been an error? Were the distances incorrect? Were the galaxies actually closer than they appeared? But as more observations arrived, the mystery only grew. Some of these ancient galaxies appeared to contain hundreds of billions of stars, far more than many scientists thought should have existed so early in cosmic history. Did galaxies simply grow much faster than our models predicted? Or are we missing something fundamental about how the universe evolved after the Big Bang? No one knows for certain. And that's exactly why these discoveries are so exciting. Science doesn't move forward by proving everything we already believe. It moves forward when observations challenge our assumptions. But distant galaxies weren't the only surprise. James Webb also turned its attention toward alien worlds. Unlike previous telescopes, Webb can analyze tiny amounts of starlight passing through a planet's atmosphere as it crosses in front of its star. That faint light carries an incredible amount of information: water vapor, carbon dioxide, methane, clouds, temperatures, even the chemistry of worlds hundreds of light years away. For the first time in history, scientists could begin studying the atmospheres of distant planets in remarkable detail. And what they found was astonishing. Some planets possess thick atmospheres where scientists expected almost none. Others displayed complex chemical signatures that challenged existing models. Several exoplanets proved to be far stranger than anyone imagined before Webb began observing them. Every new observation reminded astronomers of one simple truth: the universe is more diverse, more complex, and far more unpredictable than our theories alone can explain. Then came another unexpected discovery. When James Webb looked into enormous clouds of gas where stars are born, it revealed structures hidden for billions of years behind thick curtains of cosmic dust. Previous telescopes could only see the surface. Webb looked straight through it. Suddenly, scientists could watch stars forming with unprecedented clarity. They observed intricate filaments of gas stretching across space like glowing rivers. Massive stellar nurseries filled with newborn stars. Regions where entire solar systems may be taking shape at this very moment. It's almost impossible to comprehend. Somewhere inside those clouds, new planets are forming, worlds that may one day have oceans, atmospheres, perhaps even life, long before Earth is anything more than a distant point of light. And somehow, these incredible discoveries may only be the beginning. Because every time James Webb points toward a new corner of the universe, it seems to reveal another mystery nobody expected, another observation that forces scientists to rethink what they thought they knew, another reminder that we've only just begun exploring the cosmos. And if history has taught us anything, The next discovery could be even more unbelievable than the last. But perhaps the most fascinating discoveries aren't the ones anyone expected James Webb to make. Some of the telescope's biggest surprises came from places astronomers thought they already understood. Take black holes, for example. For decades, scientists believed that supermassive black holes grew slowly over billions of years, feeding on gas, dust, and even entire stars. According to those models, the largest black holes should have needed an enormous amount of time to reach their incredible sizes. Then James Webb looked farther back into cosmic history than ever before. And once again, something didn't add up. The telescope found evidence that some galaxies already contained enormous black holes when the universe was still incredibly young. Somehow, these cosmic giants had formed much faster than many existing theories predicted.
How?
Scientists are still trying to figure that out. Perhaps the first black holes were born much larger than we imagined. Perhaps they grew at extraordinary speeds during the universe's earliest years. Or perhaps there's a process we've yet to discover. Whatever the answer is, Webb has forced astronomers to ask entirely new questions. And that's exactly what great science is supposed to do. Then there are the planets. Before James Webb, studying an exoplanet's atmosphere was extremely difficult. Scientists could only detect a few basic molecules, and often the data was uncertain. Now, everything has changed. Webb can identify chemical fingerprints with remarkable precision. It has detected water vapor in distant atmospheres, carbon dioxide, methane, sulfur dioxide, even complex cloud structures on planets hundreds of light-years away. For the first time, scientists are beginning to compare alien worlds the way meteorologists compare planets in our own solar system. Some of these planets are unlike anything we know. There are worlds where temperatures are hot enough to vaporize rock. Gas giants wrapped in thick clouds of glowing minerals. Planets so close to their stars that a single year lasts only a few Earth days. And every new observation reminds us that our solar system is only one small example among countless possibilities. Perhaps the most exciting goal, however, is finding a truly Earth-like planet. Not just similar in size, but similar in atmosphere, similar in temperature, perhaps even similar in chemistry. If James Webb or future telescopes detect the right combination of gases, it could point toward biological activity. Not proof of alien life, but one of the strongest clues humanity has ever found. Imagine the moment scientists announce that they have discovered a distant world with water, oxygen, methane, and other gases existing together in ways that are difficult to explain without life. It would be one of the biggest scientific stories in history. But James Webb isn't only changing what we know about planets and galaxies. It's also changing the way scientists think. Again and again, Webb has shown that many of our predictions were too simple. The universe isn't following a script. It isn't behaving exactly the way our computer models expected. Instead, it's revealing a cosmos that's richer, more complicated, and far more surprising. Every image contains thousands of galaxies. Every spectrum hides new information. Every observation raises new questions. Some discoveries solve old mysteries. Others create entirely new ones. And perhaps that's the greatest achievement of the James Webb Space Telescope. It isn't giving us all the answers. It's showing us just how many questions are still waiting to be answered. Because every time Webb looks deeper into space, it also looks farther back in time. And somewhere in that ancient light, there may be discoveries that completely transform our understanding of the universe. And maybe that's the most incredible part of James Webb's mission. It hasn't reached the end of its discoveries. In many ways, it's only getting started. Every single day, the telescope sends back enormous amounts of data from the deepest parts of the universe. Most of those observations haven't even been fully analyzed yet. Hidden within that data could be galaxies no one has noticed, new types of planets, unexpected chemical signatures, or completely new cosmic phenomena that scientists haven't even imagined.
Think about that.
Some of the greatest discoveries in astronomy may already exist, sitting quietly inside James Webb's databases, waiting for someone to recognize their importance. History has shown that this happens more often than people realize. Sometimes a revolutionary discovery isn't made when the telescope observes something. It's made months, or even years later, when researchers examine the data from a different perspective. The universe has a way of hiding its greatest secrets in plain sight. James Webb is also helping prepare the next generation of space exploration. The discoveries it makes today will guide future telescopes capable of taking direct images of Earth-like planets. Future missions may identify oceans on distant worlds. They may detect changing seasons, cloud formations, perhaps even the first unmistakable signs of biological activity beyond our solar system. Imagine living through that moment. A press conference watched by millions around the world. Scientists revealing evidence that another planet may support life. Not because someone saw an alien spacecraft, not because a mysterious signal arrived from space, but because the chemistry of an atmosphere told its own story. It would completely change humanity's understanding of its place in the universe. But even if that discovery doesn't happen tomorrow, James Webb has already achieved something extraordinary. It has reminded us that science is never finished. Every answer creates new questions. Every discovery reveals another mystery. The deeper we look into space, the less ordinary the universe becomes. A century ago, we didn't know other galaxies filled the cosmos. 30 years ago, we had never confirmed a single planet orbiting another sun-like star. Today, we can study alien atmospheres, observe galaxies formed shortly after the Big Bang, and investigate the birthplaces of stars with astonishing detail. If that's what humanity has accomplished in just a few decades, imagine what the next 50 years might bring. Perhaps James Webb will discover the earliest galaxy ever observed. Perhaps it will detect the strongest evidence yet of life beyond Earth. Or perhaps its greatest discovery will be something no scientist has predicted. Because that's the lesson the universe teaches us again and again. Reality is almost always more extraordinary than imagination. So the next time you hear another headline saying that James Webb has shocked scientists once again, remember that surprise isn't a sign that science has failed. It's a sign that science is working exactly as it should. Every unexpected observation pushes humanity one step closer to understanding the cosmos. One image, one spectrum, one discovery at a time. If you enjoyed this video, don't forget to leave a like, subscribe to the channel, and turn on notifications so you never miss our next journey through the greatest mysteries of space. Because somewhere, billions of light years away, ancient light is still traveling toward us, carrying stories that began before Earth even existed. And perhaps, one of those stories will become the greatest discovery in human history.